Well, hi everyone. Working on this practice test here. First we have this function, the greatest integer function of x minus 1 plus 1. And what I'm going to do is find these values. Now, 2.4 minus 1, that is 1.4. Do that calculation, then I add 1 to that. Now, the GIF of 1.4 is 1. Remember, we go down to the greatest integer. And 1 plus 1 is 2. 1 and 7/8. Minus 1 is 7/8. Plus 1. Now, the GIF of 7/8 is 0. Go down to the greatest integer. That's 0 plus 1, which is 1. For 0.75, I subtract 1, and that's negative 0.25. And then I add 1 to that. Now this, I go down to negative 1. I add 1, and that is 0. Negative 2. Let me work on that down here. Negative 2 minus 1 is negative 3. And then plus 1. The GIF of negative 3 is negative 3 plus 1. And that's negative 2. 3 minus 1, that is 2. And 2 plus 1. And that's 2 plus 1, which is 3. Okay. Now, I'm going to draw the keystone piece here for the parent function. Parent function being this, and that's this piece right here. I'm going to take the keystone and go 1 unit to the right, that's that minus 1 in the parentheses, and go 1 unit up, and that's this one. Well, isn't this what would be the next piece? So what I'm seeing is we have, and I think if you look at our values also in this, it wasn't completely intentional, but this is, fill this whole grid up, this is the parent function as well. Shifting it 1 unit right and 1 unit up is actually is putting it on top of itself, so it is an identical function. Isn't this what, just if I just put it in this in here, I get this. If I put this in here, I get this. Notice. Okay, don't count on that for the test, but it just turns out to be an interesting result here. Alright, so let's take a look at these three graphs and get the equations for them. Notice this is the non-calculator portion. Tomorrow, or when you do this, you're going to have a page is just for non-calculator problems, and then you're going to have a page for calculator problems. So you'll do this one first, you'll have your calculator put away, and then you'll get the next part. Now, the equation for this graph, first of all, looks like the cubic function, and it looks like it's been translated some. So, and it looks like it's 1 unit left and 2 units down. So 1 unit left, that's x plus 1. 2 units, that's 1 unit right. Okay, you know my issues with left and right. They rear its ugly head again. Alright, 1 unit right is x minus 1. I only caught that when I was looking up here, and thought, there's something inconsistent I'm doing here. Now 2 units down, that's minus 2. I also noticed a flip. I've noticed that this is going down. The typical cubic function will be rising. This one's falling. It has been flipped over the x-axis, or you can call it flipped over the y-axis. Either way, with the cubic, it has the same result. Now I put a negative here. I don't know if there's a different factor here, but I don't think there is. If I go 1 unit right and 1 unit down, 1 unit left, 1 unit up. That's what would happen with the parent function. So there's no growth factor there. The second one, this looks like the quadratic that has been shifted 1 unit to the left. So let's go x plus 1 here. 1 unit, or 1, 2, 3 units down. So let's go minus 3 here. Okay, I do think we have a growth factor here. Now notice on the parent function, if I go 1 unit right, 1 unit up. Okay. So the parent value, just think about this as if it were at the, before the shift. If we were at 0, 0, the parent function would be at 1, 1. 1, if x is 1, x squared is 1. The transformed function, if this were at the origin, like say that, think of that kind of as the origin, this is at 1, 2. So what's happening here is the parent function times the coefficient is equal to the transformed on the y's. So a is 2 here, and that stretches it. Makes it a little thinner than what it would be otherwise. Otherwise be here, and then 2 4s out here, so it'd be coming out like this if it were just not, didn't have that stretch factor. Now let's take a look at, this looks like a square root function. Square root function hits 1, 1 and 4, 2, kind of comes out like this. Alright, looks like we have flipped it around over the x-axis. Now, I'm also looking that we went 1 unit here, and if I go 1, 2, and over 1, 2, 3, 4, it looks like I'm hitting again. So it doesn't look like there's a stretch or a compression factor here. So I'm going to put my square root here. I'm going to put the negative because we flipped it over. And then we have translated it 2 units to the right. So let's go x plus 2 here. And we've translated it 1 unit down. And go minus 1 outside of the parentheses there. Alright. Now, this part would probably be more along the lines of a of the calculator portion. This would be, so this would probably be all you'd have to do on the non-calculator, what we just did. And on this side of the graph or problem, we will do the calculator portion. Okay, given that f of x equals 4x minus 3 and x squared minus, and g of x equals x squared minus 25, find the following. F plus g of x, which is f of x plus g of x, which is 4x minus 3 plus x squared minus 25. So let's take x squared plus 4x minus 3 minus 25 minus 28. That's what f plus g of x is going to equal. F minus g of x, that's f of x minus g of x. So I'm going to take the 4x minus 3 and I'm going to subtract x squared minus 25. Without parentheses, I got 4x minus 3 minus x squared plus 25. I'm going to write negative x squared plus 4x minus 3 plus 25 plus 22. F times g of x is f of x times g of x, which is going to be 4x minus 3 times x squared minus 25. First, 4x cubed outside minus 100x inside minus 3x squared. Last, plus 75. Alright, in descending order of exponents, let's write 4x cubed minus 3x squared minus 100x plus 75. This is f of x over g of x. F of x is 4x minus 3. G of x is x squared minus 25. You know that would factor, but that's not going to cancel with anything up here, so I'm going to just leave it there. And then when we have to find the domain of x squared minus 25, the denominator is x squared minus 25. It cannot be 0. So I'll just kind of keep solving. I'm going to factor that. X plus 5, x minus 5 is not 0. X plus 5 is not 0. Or x minus 5 is not 0. So x is not equal to negative 5. Or x is not equal to 5. So, domain here. I'm going to go negative infinity to negative 5, negative 5 to 5, and 5 to infinity. This is the interval notation way of excluding negative 5 and 5 from the domain. Alright, composite functions, number 5 here. F of x equals square root of x, 2x plus 5, g of x equals x squared. Find the composite function here. So, f circle g, that's f of g of x, which is f of x squared. G of x is x squared. So function f says take the square root of 2 times your input plus 5. Well, my input's not x anymore, it's x squared. So I'm going to take the square root of 2 times x squared plus 5. Which is the square root of 2x squared plus 5. G of f is equal to g of f of x, and that's g of the square root of 2x plus 5. That's what f of x equals. So I'm going to take my input, my new input, and replace it with x in the g function. Alright, g of x says take your input and square it. Well, my input is the square root of 2x plus 5, and I'm going to square that, and that's going to equal 2x plus 5. Okay, the domain of f Alright. 2x plus 5 has to be greater than or equal to 0. Let's subtract 5 because it's under the radical. 2x has to be greater than or equal to negative 5, so x has to be greater than or equal to negative 5 halves. Alright, so for f, I'll put it down here, I'm going negative 5 halves and higher, all the way. Okay. For g, I have all real numbers. G of x is x squared. There's no limit on what values of x we can calculate there. Now, f circle g. G is the internal function. Its domain is all real numbers. Now, when I put any real number here, it's still going to get squared, which is going to make it positive, which means we can take the square root. So f circle g also has all real numbers for its. Now g circle f, we could put any real number in here and get an answer, but we've got to make sure the first thing you do is you do the f of x. So you're restricted there with the domain of f. Okay? Now we could put any real number in here, but we're restricted here. So you look at the inner function, and then maybe you're not on this one, but maybe you have other limitations beyond just this. But your first limitation, your first part of the domain is what is the domain of f, the inside function. And then if you have more based on this, you take that into account. But you don't have to here. Okay. Now, okay, we are on 64 from page 221. I don't know that I have enough room here, so I got another sheet of notebook paper out here to do this. 64, consumer awareness. The suggested retail price of a new hybrid car is P dollars. The dealership advertises the factory rebate of $2,000 and a 10% discount. Write a function R in terms of P, giving the cost of the hybrid car after receiving the rebate from the factory. So when it says write it in terms of P, R of P is the retail price. The dealership advertises the factory rebate of $2,000 and a 10% discount. Write a function R in terms of P of giving the cost of the hybrid car after receiving the rebate from the factory. So the rebate's $2,000, so we subtract $2,000 from the retail price of the car. There's A. B. Write a function S in terms of P, giving the discount of the hybrid car after receiving the dealership discount. Alright, so we get a 10% discount. Alright, a 10% discount, that's how much you don't have to pay of the P, but it means you do have to pay 90%. So I'm going to write that as 0.9 times P. I'm taking 10% off. You take 100% of P minus 10% of P. And that means you have to pay 90% of P. So that's that. Okay. Now, C says, find and interpret R circle S of P and S circle R of P. So let's do R circle S of P. So R of S of P, R of S of P, okay, let me concentrate up here. That's R of 0.9P. Okay, R of P is P minus 2,000. If my input is 0.9P, I'm going to take 0.9p minus 2,000. I'm going to take my input and subtract 2,000. Well, I changed my input to 0.9p, from p to 0.9p. Now, S of R of P is the second thing they asked us to find. So that's S of R of P. I find this helpful for me. R of P is P minus 2,000. So I'm going to take my input of P and change it to P minus 2,000. And I'm looking at 0.9p, and when I distribute that, minus 0.9 times 2,000 is 1,800. Okay, I think we can see already here that we're going to pay less with this way of figuring the discount than with this. You're going to take 0.9p, which will reduce it, and then subtract 2,000 from that. Here you'll take 0.9p, you'll get that same amount, but you're only subtracting 1,800 with this. All right, now D, so R circle S of 25,795 is 0.9 times 25,795 minus 2,000. All right. 0.9 times 25,795 minus 2,000 is $21,215.50. The one in there. All right. S circle R of 25,795 is 0.9 times 25,795 minus 1,800. Take this and just change this to 1,800. 21,415. All right. Taking the 90% and then subtracting 2,000 is better than subtracting 2,000 and then taking the 90% for the consumer. For the consumer. If you're the buyer, that's the way you want to go. And we just explained that. Which yields a lower cost. Taking the 10% discount first, then subtracting the $2,000 rebate second, will yield the lower price than if you reversed this, because you are taking 10% off of the rebate if you subtract first. Okay, something along those lines when you have to explain it. All right, guys. God bless you.